This is R.D. Sharma solution, class 12, chapter 19, exercises 19.8, indefinite integrals we are talking about. This is the denominator is very important here, as in the earlier questions. Just put this denominator as a t, you will see that the numerator is going to automatically come. So t equals to 2 sin x plus cos x, dt by dx will be 2 cos x, cos x will be minus sin x. What do you see? Minus sin x plus 2 cos x in the numerator. So that numerator is already there with you. What you can do? Just dx on the right hand side will make dt as the numerator. That is 2 cos x minus sin x into dx. This is already there. So just write this integral as integral sign, that symbol, and this dt will replace this 2 cos x minus sin x into dx. In the denominator it is going to be t because that's what you have assumed. So it will be ln modulus of a t plus c. So I'll just bypass one step and I'll just write what was t. So this is going to be 2 sin x plus cos x. Don't bypass this step, okay? You have to write that step. I'll show you how to do that. So this is the solution we were talking about. Next one is cos 4x minus cos 2x, sin 4x minus sin 2x. So even if we put the sin 4x minus sin 2x, it's going to be 4 cos 4x minus 2 cos 2x. And that's not going to solve our purpose because numerator will not be formed. So we need to take another approach, and that approach is only possible when we use the formula. So the formula is very important. If you know the formula, if you can recall the formula, this question will be very easy for you. Let me write it for you. It's cos A minus cos B. And we have sin A minus sin B because A and B are 4x and 2x. So cos A minus cos B is negative 2 sin A plus B by 2 sin A minus B by 2. This you already know. Then we have sin A minus sin B. What is sin A minus sin B? If you want to recall this and write this formula, let me help you here. It will be 2 cos A plus B by 2, and this is sin A minus B by 2. So cos A minus cos B, sin A minus sin B. Then we have the integration. Let us write these two in place of cos 4x minus cos 2x and sin 4x minus this sin 2x. So let us write it here. So this will be negative 2 will remain there, so I'm just writing it. Let us do this a plus b by 2 and a minus b by 2. So we will have 4x plus 2x by 2, and this will be 3x, and 4x minus 2x by 2, that is going to be x. So we'll use this directly here. It will be sine, what is a plus b by 2? Already done, so it's 3x. Sine a minus b by 2, a minus b by 2 already done, it's x. So you can just write sine x here. In the denominator, it will be cos a plus b by 2. What is cos a plus b by 2? It's 3x, so it will be cos 3x. And then we have sine x, so you can just cancel this sin x and sin x because they are common. 2 you can common, so you can cancel them out. Negative you can take outside. Sin 3x by cos 3x is of course tan 3x, and this tan 3x integration you already know because tan 3x has a standard result. Let us take this negative outside. Tan 3x ln modulus of, what is that? Tell me. It's sec 3x dx. Dx is already done, so just add the constant of integration. 1 by 3 will also be there because differentiation of 3x will be done and it will be put in the denominator, that you already know. Now you can just take this negative, and this sec x is actually 1 by cos x. When it goes with the power negative 1, it will form cos 3x. So you already know a log b is log b to the power a. So sec theta to the power minus 1, which is actually 1 by cos theta to the power minus 1, which will become cos theta only. So here, because theta is 3x, so you can just remove this negative sign, and it will be 1 by 3 cos 3x inside ln and contained by a modulus sign. That's very important. So this formula is very important. If this is the key to this question, if you know and remember this formula, then you'll be able to solve it. Otherwise, it will be very difficult to solve this question. Now, this is your solution I was talking about. I am reiterating the formula again. Next is sec x divided by log sec x plus tan x. dx. Now when we place this log sec x plus tan x as t, you will see that sec x dx will automatically come. So t is equal to log, it's sec x plus tan x, and sec x plus tan x log sec x plus tan x dt by dx will be what? Log x or log theta or log whatever inside will be 1 by that thing. So 1 by sec x plus tan x. What is sec x differentiation? Sec x tan x. What is differentiation of tan x? It will be sec square x. Okay, I am going to give you that feeling that we are going to get sec x plus tan x. How? Just take this sec x outside. When you take this sec x outside, you will get first is tan x, the second is only sec x. So what are you going to get? You are going to get the sec x plus tan x in the numerator, also in the denominator. You can cancel it. Only sec x will remain. dt by dx is equal to sec x. You can take this dx which is in the denominator to the right hand side. The dt will be equal to sec x dx. Now this I, which is the integral, is equal to integral sine. This dt is actually sec x dx and the denominator was t only. So it will be ln modulus of t plus constant of integration. I am saving one more step of myself. I am writing directly t here. Don't bypass that step. You have to write it, right? So ln modulus of log sec x plus tan x and plus constant of integration. So this is the result. Okay, this is the result. Just assume that log x is log base ex and that will solve your purpose. Just take t from the denominator and assume this denominator as t. Numerator will come by itself and it will be simply log t plus c, and t of course what you have taken, just replace it and that will be a solution. Next one is almost similar to the question we have just covered. So when you take this log 10x by 2 as t, you'll see that the differentiation will give you cosec x dx. So t equals to log 10x by 2, dt by dx is going to be equal to, this is log is 1 by that thing, so 1 by 10x by 2, and 10x by 2 will be sec square x by 2. And please remember that this is x by 2. So this x by 2 has to be differentiated and kept like this, half. I've kept it in front. So this sec square is 1 by cos square. Tan is sine by cos. So what are you going to get? Just cancel one cos. This sine goes up. It will remain in the denominator because it will be eventually 1 by cos square into cos 6 by sine x. So 1 by 2 sine x by 2 cos x by 2, because of course it's x by 2. 2 sine theta cos theta is a sine 2 theta. 2 sine x by 2 cos x by 2 is sine 2 into x by 2, which is x only. So 1 by sine x you got. Now you need this cosec x in the numerator. So you just take it into the numerator. It will be cosec x. So let me tell you again. 1 by sine x is cosec x. So dt is equal to cosec x dx from here. Now this numerator was already cosec x dx. You can just write dt in place of cosec x dx. So this integration is going to become integration of integration sign. Cosec x dx will be dt. Denominator will be log 10x by 2. And this dt by t will be ln log, basically modulus of t plus constant of integration. Let me write t directly here. That step you are going to write. So log modulus of log 10x by 2. Kindly use the brackets. It will definitely tell the examiner that these are different parts of a term, and constant of integration of course to be added. So this is the result I was talking about, we just discussed, and all this putting and note, all this you have to write. Okay, this question might seem to be a new question for you, but you see, log x, the differentiation of log x is simply 1 by x log x. If you do it once, next time this question will come to you, you will be easily be solving this question. So t is equal to log x. These are all different, so kindly try and make a habit to keep everything separated by using the comma. By the brackets. That's very important. dt by dx is what? 1 by log x. What is differentiation log x? It's 1 by x. So it's just 1 by x log x. dx can be taken on the right hand side. So from here till here, what do you get? It's simply dt. So integration becomes this integral sign. numerator is here, so dt, you can just replace the numerator by dt, and since t was log x, it's simply integration of 1 by t, which is log modulus t plus constant of integration. So let me write it, log modulus t plus constant of integration. The t was initially assumed to be log x. Now replace this here in place of t, it will be log x. So there are number of logs here, that's why this is the answer. So this is what you have to write actually, because explanation is something different and writing is something different. Writing gives you marks and explanation gives you understanding. Understanding is as important as writing the solution on the paper. So again, 1 plus cot x can be directly placed as t, and you'll get cosec square x dx directly. So t is equal to 1 plus cot x. When you differentiate this, dt by dx is going to be, cot x is minus cosec square x. When you have this minus cosec square x, because you need cosec square x only, so negative will go on the left hand side. So dt is actually minus cosec square into dx. Because you want only cosec square dx, negative can be taken on other side. So this cosec square dx completely becomes now negative dt. So negative you can take outside dt. Denominator is 1 plus cot t, which was t only. Again the same thing. You can just take log modulus t plus constant of integration with a negative sign. So I'm just writing the direct result now. It will be minus log modulus of 1 plus cot x. If you replace t by 1 plus cot x, which you eventually have to do, and 1 plus cot x here, and with the constant of integration. This is your answer. So this is how you are going to write. It's very straightforward. All these questions, just put the denominator as t, you'll get the numerator. And log is the answer. Now this question again seems to be a different sort of question, but don't worry about that. The denominator will give you exactly the numerator. That is, if you put t equals to 10 raised x plus x raised 10. When you differentiate this dt by dx, this 10 raised x, a raised x, the differentiation of a raised x is a raised x log base e a. A is 10 here. So wherever a is there, just put 10 and keep it here. So 10 raised x log base e 10 plus x raised power 10. So it is nx to the power n minus 1. Wherever n is there, just write 10. So 10x to the power 9. So you have this result. Now what do you see? Numerator and denominator and this result are exactly similar. So you can just replace this whole numerator with dt. As you see here, when you take this content and multiply it by dx, which is coming from the denominator of the left hand side, you'll get dt. So dt, denominator is t, again the same result, log modulus of t plus constant of integration. I'm writing the direct result now. Don't skip that in between step. So ln modulus of 10 raised x plus x raised 10, and just add the constant of integration. So this is how, at first glance you might feel how do we solve this, but if you do the practice, it's very easy for you. Next, this type of question I think we have already done. So just take this x plus cos square x as t. When you differentiate this dt by dx, it's x is 1, cos square x will be 2 cos x, and cos x will be minus sin x. So I'm writing negative here. 1 minus 2 cos x sin x, so you can just write it as 2 sin x cos x, which is sin 2x. Let me tell you again. Sin 2 theta is 2 sin theta by 2 cos theta by 2. That is, sin 2 theta is 2 sin theta cos theta. Sin theta is 2 sin theta by 2 cos theta by 2, and it goes like that. But here just write 1 minus sin 2x. Take dx on the right hand side. This whole is dt. You can just write I as integration of the numerator becomes dt and denominator becomes t. So we have log modulus of t plus constant of integration. In place of this t, write x plus cos square x. So ln modulus of x plus cos square x plus c. So this is the result now. So if you have been following me, I hope that you have understood the concept now. Now this log base e, first of all assume that log is base e, and you will see that how do we write this? Can you do it by yourself? Because it's very evident that when you put this denominator as t, which is x plus log sec x dx, when you differentiate it dt by dx, you'll get what? This dx which is in the denominator is actually upstairs. It should be in the numerator. So 1 plus 1 by sec x tan x. Sec x gets cancelled. 1 plus tan x will directly come. So this dt is nothing but 1 plus tan x into dx. So this whole is dt only. So it's very straightforward now. We have integration. This is dt. Modulus of log modulus of t will come. So integration of dt by t, which is I equals to integration of dt by t, is simply log modulus of t. Let me write it directly. X plus log sec x plus constant of integration. Just use the bracket. That will make the examiner more happier. So this is how you are going to go about it. This is the solution, and writing is your idea. You need to write in your way. So this again question have been visited already, and we are going to do it quickly. You see sin 2x is there, and you know differentiation of sin square x is sin 2x only, because 2 sin x cos x sin 2x is there. So when we have t equals to sin square x, when you differentiate it dt by dx, it's 2 sin x, and differentiation of sin x is going to be cos x. So dt becomes 2 sin x cos x into dx. So 2 sin x cos x is sin 2x only. So dt is equal to sin 2x dx. Numerator is directly in our hand. So I equals to the numerator, which is sin 2x dx, can be replaced by dt, and a square plus b square t. Don't worry about the square or cube or whatever, because these are just constants. Don't worry about that. So 1 by ax plus b, a square, b square, a cube, b cube, whatever it is, doesn't matter. The result remains the same. 1 by a ln, and then the modulus of ax plus b plus c. So a b square is taking the place of a here. So 1 by b square ln modulus of a square plus b square into t plus constant of integration. One more step is remaining. T was sin square x, which we assume. Replace t by sin square x. So 1 by b square ln a square plus b square into sin square x plus constant of integration is your final result, because t was sin square x initially we assumed. So this is the final result. You need to write it exactly what I am showing it to you. This question will be taken in the next discussion. Till then, have a good one. Bye-bye.